Talking about how we use simulation to be able to help design state-of-the-art, safe, comfortable, and energy-efficient HVAC systems from the component all the way to the integrations into the buildings. To get us started, let's talk about some of the major challenges in this area. If we look at the built environment and we look at future buildings that will be going up or renovations that will be coming forward, we need to eliminate all of the CO2 emissions from new buildings being built and even have negative CO2 emissions on new builds to be able to meet our 1.5 degree climate targets. And this is a conclusion that was drawn by Architecture 2030 when looking at the state of building emissions around the world. And so throughout this presentation, I'll be coming back, touching upon this topic of energy savings and energy efficiency. But we'll need to maintain, while providing solutions that ensure high levels of energy savings and cost savings, a safe and a comfortable environment as well. Now, how did we get to this stage? Well, if you look at some of the statistics which are available here from one of the United Nations report, and here I'm showing the 2020 results, but the 2021 results are very similar. The building industry is actually responsible for the majority of CO2 emissions worldwide. So it's 38% overall. And if we look specifically within that building industry, the operations of buildings, which means what happens after the construction, is responsible once again for the majority of those building emissions. Now, we'll need to decrease considerably the emissions of these buildings to be able to meet our targets. The graph on the right-hand side shows the objective targets to be able to meet our 2030 and 2040 objectives in blue, and our current progression in orange. And as you can see, immediately after the Paris Accords, we did quite well, decreasing energy consumption from the building sector. And as we progressed and each year went on, we've been getting further and further away from that target curve. Now we're going to be looking at one specific aspect of building operations and building energy consumption. And if we look once again at the statistics, HVAC and ventilation are actually responsible for 20% of the worldwide electricity consumption. So it really makes sense to focus on those components and on those devices, both in the design stage for the components and in the integration in the building. Now, beyond issues with climate change, we're also looking at new legislation. Legislation which is attempting to push towards greener systems, but also forcing redesigns of existing technologies. If we look, for example, at the Kigali amendments, they are restricting the use of specific refrigerant gases. And this means a re-engineering of all of the chiller loops involved in HVAC systems. Similarly, some of the LEED initiative tax credits available in the United States are pushing towards integrating more energy efficient components. And we're looking at obtaining a 10% worldwide energy consumption reduction just by using new technology, whether it's variable flow speeds for fans and compressors, or even ice block technology in your basement. Now, all that's great, but we need to impact also the end owner, right?